Let's say we have a 3-volt supply and we want to connect a single red LED. What resistor do we need? Well, we know this wire is 3 volts and this one is our ground wire, which will be 0 volts. The LED has a voltage drop of around 2 volts, and so our resistor needs to remove the remaining voltage. So 3 volts subtract 2 volts equals 1 volt. We know the LED needs a current of around 20 milliamps. So 1 volt divided by 0.02 amps equals 50 ohms of resistance. Make sure you convert your milliamps to amps for this calculation. To make it easier, we do have a calculator on our website where you can just input your values. I'll leave a link in the video description down below for that. Okay, now you try to solve this one before I do. Let me know your answers in the comment section down below. Let's say we have a 9-volt battery and we want to connect a yellow LED which has a voltage drop of 2 volts and requires 20 milliamps of current. So what size resistor is required? Well, we have a 9-volt supply, so subtract 2 volts for the LED, and that leaves us with a 7-volt drop for the resistor. The current is 20 milliamps, so 7 divided by 0.02 amps equals 350 ohms of resistance. Now, the problem is that we don't have a 350 ohm resistor. We only have a 330 ohm or a 390 ohm. So which one should we use? As we saw earlier, we need to ensure the current doesn't exceed 20 milliamps. So we will have to calculate which resistor suits us best. To do that, we just divide the required voltage drop of 7 volts by the resistor value of 330 ohms to get 0.021 amps. And then if we do the same for the 390 ohm resistor, we will get 0.018 amps. Both of these values are very close and they both will work. But to be safe, we will choose the 390 ohm resistor as our LED will therefore last longer. We can also combine resistors to get the exact value we need, and I'll explain that a little later in this video. We will also need to choose the resistor power rating. We can calculate this using the formula power equals current squared multiplied by resistance. So 0.018 amps squared multiplied by 390 ohms gives us 0.126 watts. So a 1/4 watt rated resistor will be fine for this circuit. How long will this battery power our circuit for? Let's say this battery is rated for a typical 500 milliamp hours. We simply divide this by our total circuit current, which in this case is 18 milliamps. So 500 milliamp hours divided by 18 milliamps will give us around 27 hours. Although this is the very maximum it would power our circuit for, in reality it probably will not achieve this. Okay, that's it for this video, but to continue learning about electronics and electrical engineering, check out one of the videos on screen now and I'll catch you there for the next lesson. Don't forget to follow us on Facebook, Twitter, Instagram, LinkedIn, and of course theengineeringmindset.com.